Hello student, I am teacher Eda. Today we are going to learn about resultant force in 15 minutes. This topic is located in 1.1 resultant force in Form 5 Physics syllabus. So, at the end of this lesson, students should be able to first describe resultant force, second determine the resultant force, third communicate about resultant force F when an object is at stationary, moving with constant velocity, moving with constant acceleration, and the last one is students should be able to solve problem involving resultant force, mass, and acceleration of an object. Okay, now let's move on to the first lesson, which is to describe resultant force. What is resultant force? Resultant force is the single force that represents the vector sum of two or more forces acting on an object. Don't worry student, let's proceed to the picture provided for your better understanding. For the situation 1, both participants in a tug-of-war competition in at stationary state. At this state, when two forces of the same magnitude acting in opposite direction, the object is remain at rest. Different from situation 2 and 3, two opposing forces have different magnitudes. The object will move in the direction of the larger force. Alright student, we are going to learn about how to determine the resultant force. Okay, now, how to calculate the resultant force when two forces acting in the same direction. As we can see, the first one is 6 Newton while another force is 8 Newton. To calculate the resultant force, you just need to add both forces together, where F equal to 6 plus 8 and the answer is 14 Newton. The direction is to the right, since the direction of both forces is to the right. Okay, next, how to calculate the resultant force when two forces acting in the opposite direction. What you need to do is adding both forces together, where F equal to negative 8 Newton plus 6 Newton. Why negative 8? It is because the blue forces move to the left. So, the answer is negative 2 Newton. The resultant force is 2 Newton to the left. Why to the left? It is because object will follow in the direction of larger force. 8 Newton is larger than 6 Newton. Okay student, let's move on to the next situation where forces acting to an object that is perpendicular to each other. Okay. Step 1. Draw a rectangular of forces that are perpendicular to each other. Step 2. Draw a diagonal of the rectangle to represent the resultant force F of the two forces. Step 3. Using Pythagoras theorem, you can easily find the resultant force, where F equal to square root 6 square plus 8 square. You will get the answer F equal to 10 Newton. Step 4. After that, you may also find the value of the angle by tan theta equal to 6 divided by 8 Newton, and you will get the value of the angle is 36.9 degree. Next, how to calculate resultant force when the forces are not perpendicular to each other. There are two methods that we can use. The first one is by using triangle of forces method. And the second one is by using parallelogram of forces method. Let's learn how to use the first method, which is the triangle of forces. This picture shows forces that are not perpendicular to each other. What you need to do is Step 1. Draw F1 followed by F2 to form two sides of a triangle. Step 2. Complete the triangle by drawing the resultant force F. Step 3. At this step, You can now measure the length of side F and calculate the magnitude of the resultant force using Pythagoras theorem. Okay student, let's proceed to the second method. The first image shows two forces that are not perpendicular to each other. Step 1. By using ruler and protractor, draw the F1 and F2 from a point to form two adjacent sides of a parallelogram. Step 2. With the aid of a pair of compasses, complete the parallelogram. Draw the diagonal from the point of action of the forces. The diagonal represents the resultant force F. Then, measure the length of the diagonal and calculate the magnitude of the resultant force using Pythagoras theorem. Okay student, are you ready? Let's proceed to the next lesson 1.1.3 resultant force when the object is at stationary, object moving at constant velocity, and when object moving with constant acceleration. As we can see here, when the car in its stationary state, the velocity, the acceleration and resultant force are zero, and the weight of the car is equal to the normal reaction R. Next, when the car moving with a uniform velocity, the acceleration and resultant force are equal to zero. The direction of engine thrust to the right and the frictional force is to the left. And the last one is when the car is moving with uniform acceleration. The velocity is increasing. The acceleration and resultant force are not equal to zero. The weight of car equal to normal reaction. The engine thrust T is greater than frictional force, and resultant force F is equal to thrust minus frictional force. Last topic is to solve problem involving resultant force, mass and acceleration of an object. In this lesson, we are going to recall the use of force formula, which is F equal to ma. Okay, let's see the image. The image shows a coconut of mass 2 kg is falling with an acceleration of 9 meter per second square. Calculate the resultant force that acting on the coconut. Answer the question by using F equal to ma, where mass is 2 kg and acceleration is 9 meter per second square, and you will get the answer force equal to 18 Newton. Easy, right? So, to test your understanding, let's do this quick exercise. Exercise 1. The figure shows a trolley of a mass 1.2 kg being pulled on a table by a load through a pulley. The trolley moves with an acceleration of 4 meter per second square against a friction of 6.9 Newton. Number 1. Calculate the resultant force acting on the trolley. Number 2. Calculate the tension in the string pulling the trolley. Number 3. What is the mass of the load M? You have 10 minutes to answer the question. Answer for question 1. Use formula F equal to ma. The mass is 1.2 kg. The acceleration is 4.0 meter per second square, and you will get the resultant force 4.8 Newton. Answer for number 2. Calculate the tension. The resultant force is 4.8 Newton and the friction force given is 6 Newton. Using formula tension T equal to resultant force plus friction force, you will get the answer tension T equal to 10.8 Newton. Answer for number 3. Calculate the mass of the load. First, you need to find the resultant force using F equal to ma. Given acceleration A is 4.0 meter per second square and value of m is unknown, so you will get F equal to 4m. Next, you need to find the weight of the load B. By using formula B equal to mg, m is unknown and the value of g is given 9.81 meter per second square. You will get the value B is 9.81 m. By using formula F equal to B minus T, where F is 4m, B is 9.81 m, and T is 10.8 Newton, the mass of load is 1.86 kilogram. Exercise 2. The figure shows a passenger of mass 90 kg is in the lift. Calculate the magnitude of the normal reaction R when the lift is first, at stationary, second, moving upwards with an acceleration of 1.2 meter per second, third, moving with a uniform velocity of 8.0 meter per second. Given the gravitational acceleration g is equal to 9.81 meter per second square, you have 10 minutes to answer the question. Okay, so this is the answer for question number 1. When the lift is at stationary, the resultant force is equal to 0. So, the normal reaction R is equal to the weight of the passenger. So, R equal to mg. M is 90 kg and G is 9.81 meter per second square. You will get the answer normal reaction R is 588.6 Newton. Okay, let's proceed to the answer for question number 2. When the lift is moving upwards with an acceleration of 1.2 meter per second square, we can use formula F equal to ma. F is equivalent to R minus W equal to ma. So R minus 588.6 Newton equal to 60 kg multiplied by 1.2 meter per second square, you will get the normal reaction R 660.6 Newton. Okay, this is the answer for question number 3. Calculate the normal reaction R when the lift is moving with a uniform velocity of 8.0 meter per second. When moving with uniform velocity, the resultant force is equal to 0. This given the formula normal reaction R equal to weight of the passenger. So, you will get the value of R is 588.6 Newton. That's all for today, student. Hope you understand and enjoy the lesson. See you again. Thank you and bye.